Trig, okay. Cool.
Yeah.
Tell me where you want to start.
Can we just go through the whole package?
Okay. All of this writing is your writing, trying to solve it?
Yeah.
Okay. Let's see what the best way. Let me show you what I think is by far the best way to handle these kind of problems. It's really simple. Okay? Whenever they give you one trig function, cosecant of theta equals 17 over 15, the way to solve the problem is to draw a triangle, a right triangle, and label theta. That's extremely important. Now, dimension that triangle for me. What two sides can you dimension?
What? Sorry, my mom like
I'm sorry, what's going on?
My mom just walked in and was distracting.
Okay, so we've got the cosine of theta equals 17 over 15. I've got a triangle and I want to dimension two sides of it based on that cosecant. What two sides can I dimension?
The hypotenuse and the opposite.
Okay, so the hypotenuse is what?
The hypotenuse is 17.
Okay, and the opposite is 15. In other words, cosecant is hypotenuse over the opposite. Now, using the Pythagorean theorem, that allows us to dimension the third side. And that's the key thing. So, you have your calculator?
Yeah.
Do 17 squared minus 15 squared and take the square root of your answer. In other words, solve that. I don't need to tell you how to do it, really. If you don't know how to do it, then we need to talk about that. But
I know how to do it.
Okay. Give me a value. Give me a value for that.
When I did this problem, I didn't know, they didn't say it was the right. I guess it has to be a right triangle.
It has to be a right triangle, yeah. Because that's the only way that it allows you to dimension the third side. And that's the key to the whole problem. Once I dimension the third side, then I can tell you all 6 trig functions of theta. They only want to know cosine, but I could actually list all 6 of them. The key is finding this third side.
Okay.
What is it?
Here, I'll do it. Okay, 15, 17, 17.
Okay. So that's one of your Pythagorean right triangles. 8, 15, 17. Okay, now tell me what the cosine of theta is.
The cosine of theta would be, you just have to
use this triangle. What's cosine of theta?
It would be opposite of your hypotenuse.
Oh, you got to know SOHCAHTOA.
Yeah, I know.
You don't know SOHCAHTOA, you're lost here.
I'm not, I'm just...
Okay, so what's cosine?
You have to do the inverse.
No, it's the adjacent. The ka of SOHCAHTOA is adjacent over hypotenuse, so it's 8 over 17.
Yeah. When you have to, you put that in, then you find the inverse.
No, you don't. It says the answer is find cosine of theta. We just found the cosine of theta.
Oh, you mean you wanted to keep it like that? Okay.
They didn't ask to solve for theta. And notice one thing about this method. I never did find theta. I don't care what theta is. You don't care what theta is. In other words, that would be the hard way to do the problem, is to solve for theta based on the cosecant of theta being 17 over 15. If you have an Nspire calculator, you can solve for theta. And then you could take the cosine of theta to get the answer. But that's the hard way to do it, and that requires you to solve for theta. This way does not. And this is by far the best way, trust me.
Okay, yeah, I just was
So let's do 2. Here we have the tangent of theta equals 21 root 22 over 44. And they want to know the secant of theta. What's the first step?
Draw the triangle.
And label theta. Because notice there's 2 different angles that could be theta. I could have this angle up here be theta. Wouldn't matter. Problem would work the same. But just out of the sake of consistency, I usually make that theta. Now, label as much of this as you can. Label 2 sides of this.
Opposite would be 21 root 22. And adjacent would be 24.
Okay. Now that's going to allow you to figure out the hypotenuse. What's the hypotenuse?
My hypotenuse would be like use Pythagorean theorem.
Yeah, let me give you some help on solving right... Oh, sorry. Didn't mean to do that. Hold on. Let me back up. Solving right triangles. It's true you're going to use the Pythagorean theorem, but I hate to see you go all the way back to the original Pythagorean theorem every time you do it. There's only 2 right triangle problems to solve for. One is where you're solving for the hypotenuse, and it's equal to the square root of the squares of the other 2 sides, the 2 short sides. And the other is solving for one of the short sides, and that's equal to the square root of the hypotenuse squared minus the other short side squared. So you really should try to memorize both of those. It's gonna take 30 seconds off your solving right triangles. And particularly with these kind of problems, they're all about solving the right triangle, right? I mean, the only tough step here is figuring out this third side. And if you do it this way, it's just so much quicker than starting with c squared equals a squared plus b squared and then having to do all the algebra to figure out how to solve for c. Instead, memorize both of these. One solves for the hypotenuse, the other solves for one of the short sides, and it doesn't matter which one. If you're solving for b, then it's b equals square root of c squared minus a squared. Okay, so we're going to use this one here. So we got the square root of this number squared plus 44 squared. What is that number?
Let me put it in my calculator real quickly. That's what I was doing before, exactly this.
Okay. No, I wasn't criticizing. I was just wanting to make sure you were starting at this step as opposed to going all the way back to the Pythagorean theorem.
Okay. It's rounded, it's 49.
Okay. Now, let me just do a quick calculation in my head. That doesn't look like it's possible. First of all, let's have a look at this number right there.
Maybe
Okay.
here, I think I know. It might have just been a calculator thing.
Well, but
it probably just took the root of...
Just a second. I still want to tell you about this. Because when you're doing math, you should always be doing ballpark checks. You should be seeing if that answer makes sense. Well, the reason it didn't make sense to me is because it doesn't appear to be the longest side. In other words, how long is 21 times root 22? Well, root 22 is more than 4, so that'd be 4 times 21. So this side over here is 82. So there's no way we can have a hypotenuse of 49.
Here.
You still trying to solve for C?
Yeah, I'm never going to put it in the calculator like that.
Well, it's difficult to do that in a calculator because you don't want to make a decimal out of square root of 22 because that's going to get squared and become 22. In other words, here's what we're looking at. We're looking at the square root of 21 squared times 22 plus 44 squared. That's the number we want. In other words, remember, when you square this quantity here, you square the 21 and you square the root 22. And when you square root 22, it just becomes 22. I would think this would be a whole number. I can't imagine why they would give you something that was not a whole number with these giant sized numbers they're making you deal with here. What's the point of that? You know what I'm saying? I mean, here they're making you waste 5 minutes doing this on your calculator. That 5 minutes could be much better time spent.
Yeah, my teacher sort of sucks.
Well, I see this a lot with students where they get into using these big numbers thinking they're making it more complicated, and they are, but the only thing they're doing is forcing you to spend more time doing arithmetic. We don't want to spend our time doing arithmetic. But we need an answer for this so that we can figure out what the secant of theta is, because the secant of theta is going to be dependent on this hypotenuse length.
Yeah. Could we,
You want me to do it?
Because, like, it's a small portion of the test here to...
I can't understand what you're saying.
Would we be able to move on to this after this problem?
Sure. If you're comfortable, you know how to do these, and I think you do. In other words, the only thing we need to do is come up with a number for this problem. So I get 9,702 plus 44 squared. 44, I'm doing this on a calculator that doesn't have a lot of keys. That's 1936. I got to add that to 9,702. I get 11,000, and then I want to take the square root of that. I get 107 and change. He didn't even make it a round number. 107.8.
My calculator is in radians.
Well, that really shouldn't matter when you're doing this problem. And here's why. You never are putting in an angle. Solving the Pythagorean theorem has nothing to do with degrees or radians. So all we're doing is solving for a side length. Okay. Now, if you were doing this the hard way, where you were solving for theta first, then it would matter what your calculator is. But if you're doing it the way I'm showing you, you should never be solving for theta. There's no need to solve for theta. All right. So what's the secant of theta?
the secant, it should be equals.
Just read it off my...
It should be 44.
No,
No,
see?
it should be 107.8 over 44.
There you go. All right. So you want to move to 5?
Those ones I know how to do. Those are just like, you know.
You tell me what you want to look at next.
Could you just look over what I did for 7 and 8? If I did it right, I'll do this.
Okay, hold on a second.
Just look it over yourself, like.
Yeah. No, I get it.
Then let's do.
Hold on.
Let's do.
If you're going to draw a picture like you did, make sure you label it A, B, and C. Because otherwise I have a hard time following what's going on. I can see that, here, let me do this. Here, this will work. Just a second. Let me figure out how to blow this up a little bit. Alright, so if this is the 50 angle, this must be A here.
Yeah.
And B, since B is 13 here, this must be angle B there, which would leave C to be the right angle. Okay, so we've got the sine of 53 is equal to 13 over H, and that allows you to solve for H. What's this 0?
That's opposite.
Oh, okay, so the sine of 37 is opposite. Okay, and there's only one variable in each of those. So as long as you can solve, in other words, can you solve this?
Yeah.
Equals 13 over H. You know how to solve that for H?
Yeah, you just do 13 over sine 53.
Correct. Okay, good. You see why it's a little easier if I label everything?
Yeah.
Just not from your perspective, because you know what you're... I would say even from your perspective, you want to always label your triangles, especially when everything is given in terms of A and B. Otherwise, it's really easy to make a mistake. Okay, number 8. This is A. And since that's C, that must be B. And we got C of 9.4. And we want to know what little b is for little a. That's the conventional way of labeling triangles, is you use the capital letter for the angle and you use the small letter for the side length. So we've got the sine of 47 equals a over 9.4. That's easily solved. And you've got the cosine of 47. I would just use the same angle, just a different trig function, equals b over 9.4. Notice there is one advantage in having your variable in the numerator, and that is you only have to do one thing for each of these. Whereas when we did this one up here, our variable was in the denominator, and a lot of people kind of get stuck here. As long as you know how to do this one easily, that's fine. But it's easy to run into a kind of a brick wall there. All right, let's go back and look at 9.
Yeah, could you, basically what I was thinking for those is like, I'm going to just turn them all into degrees and then turn it back into radians.
That's fine. That's fine. When you're first learning trig, that's the best thing to do. once you're in trig for a while, you kind of get so you think in terms of radians, and it's almost easier to leave everything in radians. But now you're supposed to do these without your calculator, correct? 9 through 14?
No, they don't say you don't. They don't say that.
They mean that. Trust me.
Yeah, but they won't enforce it on the test, so it doesn't even matter.
Seriously?
Yeah, he's going to let you use the calculator because he's too lazy to make a calculator section.
Well, I have extremely mixed feelings about that. 50% of learning trig is learning how to do these common angles by hand without a calculator. 50%. So he's skipping 50% of trig by letting you use a calculator on these, because you don't need my help to do these on a calculator, right?
Well, did I do them right though?
I don't know. I would have to do them on my calculator. I know how to do them by hand, and I think the intent, because notice what the instructions are in the next section. Use a calculator to find these. That's because they're odd angles. 255 is not one of your common angles, nor is minus 54. But these are all your common angles. The way you're supposed to do these is to figure out the reference angle and know all of your first quadrant trig functions.
Yeah, I do know that. Like, basically you go, I'm starting to forget, okay.
Let's try that, because it's not that hard, okay? First of all, when you are dealing with negative angles, the best thing to do is to turn them into positive angles. And there's two ways you can do it. I don't know if you've been taught both ways. But first of all, what's the positive angle for the secant of minus 225?
It would be, let me see. It would be,
add 360 to that number. And that's how you get your answer.
I'm 35, I was doing that. I'm just slow with my calculator.
Okay. So it's the equivalent of taking the secant of 135. And what is the reference angle when you're dealing with an angle of 135? I usually put the reference angle in parentheses.
Let's see, it would be,
180 minus that number.
45.
So the problem comes down to, let's figure out the number of the secant of 45, and then we'll figure out whether it should be plus or minus depending on which quadrant it's in. Okay? What is the reciprocal function of secant?
Cosine.
So what we're really looking at is 1 over the cosine of 45. What's the cosine of 45?
X.
Not x, it's 1 over root 2.
Yeah, but yeah, that's true.
Okay, and what that means is that the secant is root 2. In other words, this is one case where it really was better not to rationalize the denominator. Because here's what happened. The cosine came out, or this is what we had, 1 over root 2. That's what the secant is. Okay, well, you flip and multiply, you just get root 2. And now the last step is to put a plus or minus sign on it. And that's the way I do all of these. And that's the way you should do them all, I think. That's the way it's a consistent step-by-step process that never changes. Is secant plus or minus in the second quadrant, which is where 135 degrees is. Is it plus or minus in the second quadrant?
Minus. No, the second quadrant, yeah, it'd be minus.
Okay, so there's your answer, minus root 2. Okay, now let's look at number 10. The cotangent of 11 pi over 6, which quadrant is that?
It's the fourth quadrant.
Okay, we'll just make a note. What is the reference angle? You can do it in degrees, but you're going to find that it's going to be easier to do in radians.
It's 330.
Okay, so it's 30 degrees is the reference angle. Or pi over 6. See why pi over 6 is almost easier? Because pi over 6 is what you get when you subtract this from 2 pi. And then we know pi over 6 is 30. So sometimes it's going to be easier to work in radians until you get that first quadrant angle, then convert to degrees. Now, what's the cotangent of 30 degrees?
Cotangent, it would be x, y over x.
Okay, use numbers. Here's the way you're going to get the numbers. You're going to look at this triangle over here. That's the 30-60 triangle. And that's 1, that's root 3, that's 2. The reason I've been asking you to memorize this for a long time is because this is how you get all your first quadrant trig functions.
Yeah.
It's from that triangle and this triangle, the 45, 45. And that's 1, that's 1, that's root 2. So, the way I do cotangent is I figure what is the tangent and take the reciprocal of it. Well, the tangent's 1 over root 3. Therefore, the cotangent is just root 3.
Yeah.
Now, what is its plus or minus sign in the fourth quadrant?
It would be minus, or plus.
No. Remember, all students take calculus. All students take calculus. The only thing that's plus in the fourth quadrant is cosine and, of course, secant. But tangent is negative in the fourth quadrant. So I'm going to put a negative sign in front of that root 3. And that's the way these were meant to be done. Whether you want to do them like that or not is your choice. I mean, you can tell me. It's your tutoring session. But this is a very healthy skill to have for trig. Whether it's this year or next, I don't know when, but you're going to have to know how to do these without a calculator. If your teacher is letting you guys slide this year, is this, Sam, are you taking Algebra 2 or are you taking Algebra Trig?
I'm taking Algebra 2 Trig.
Okay, so you're taking the Trig course. You're not going to take Trig again next year.
I'm taking college algebra next year. College algebra.
Right. Well, college algebra and just college algebra. There's no trig involved in that. So this is as high up as you're going in trig. Probably. I might be wrong, but
I think it's college algebra and trig.
Oh, is it? Okay. Well, then they may get into trig a little more in depth. And then for sure you would have to know how to do these. But you're pretty close. You just about know how to do these manually. Let's do this one. One last one. What's the tangent of 5 pi over 3? What's the reference angle?
The reference angle would be 60. Would be 60, 120. When it's 30, you can add
okay, you're doing it the hard way. Let me show you the easy way. I'm going to take this angle and subtract it from 2 pi, which is 6 pi over 3, minus 5 pi over 3. What do I get?
1 pi over 3.
Now, if you want to convert it to degrees, that's much easier to convert to degrees.
Yeah.
What is that? What angle?
That in degrees would be 60 degrees.
Yeah, remember when you have just pi in the numerator, then those always multiply to 180. That's the easy way to do it. So pi over 3 is 60, pi over 6 is 30, pi over 2 is 90, so forth and so on. So now look at my triangle. What is the tangent of 60?
The tangent of 60, 60 degrees, tangent would be like y divided by x.
You keep doing that. I'm not sure why. You're supposed to be filling in these numbers. What's the opposite side to 60?
The opposite side of 60 is root 3.
Okay. What's the adjacent side to 60?
The adjacent side would be 1.
Okay. So, square root of 3 is our answer. Now let's put a plus or minus sign on it. We're again in the fourth quadrant. That's fourth quadrant. So what's tangent in the fourth?
Tangent would be negative.
Okay. Now, just for the heck of it, I want you to try doing that in your calculator. Put in the tangent of 5 pi over 3. See if you get a decimal or if it gives you negative root 3. Because if it's fine if you are allowed to use a calculator to do these, but let's make sure you're going to be able to answer with a proper answer, not a decimal answer.
It's just he lets us use the calculator to convert it into degrees. Like if you can't do the rest of it.
Oh, okay. Well, I mean, you could put your calculator in radian mode, right?
Yeah, I guess. He lets you do it like.
Okay.
He gave us a quiz where.
Okay.
Like,
I think we should continue 12 through 14. Doing it without a calculator. First of all, there's no point in us doing these if you're going to do it on a calculator, because I'm not doing anything. You're doing it all. You're going to write down the answer. And we can go to the next set of problems. But I still am convinced that we should go through doing these manually.
Okay, yeah. I'm just looking at the other page. I think, yeah, I pretty much know how to do all of this. The stuff later in this is like more formula driven.
Okay. Well, we've got 22 minutes. So you try to figure out how we should prioritize our time here. What should we be working on in the 22 minutes?
We can do the rest of these
problems. Okay. I think this is a great skill. You almost have to have this skill to be able to go forth in trig. And by that I mean being able to do these trig functions of these common angles. Now, what's the first step on 12?
You just find whatever angle that connects with it.
Tell me what the first step. Don't describe it. Tell me what the first step is.
Find the opposite angles.
When I ask that question, what I mean is add 360 to that angle.
Yeah.
To give you cosine of 300 degrees. That is the same problem as the cosine of minus 60.
Yeah.
Now what? What's the next step now?
Basically you put it means...
No. Find the reference angle. And by the reference angle, I mean, what is the equivalent first quadrant angle to 300?
Let me think. Would it be 300?
Here, look down on the unit circle where I've drawn this.
It would be 30.
No. This is 180 minus theta. This is 360 minus theta. And this one is theta minus 180. Those are the three formulas you use to figure out the reference angle. So we're in the fourth quadrant, so it's 360 minus 300. The equivalent reference angle is 60 degrees. That's the way you do it.
Okay.
So if you're going to memorize something, definitely memorize that. That allows you to use this technique. Now, look at the triangle and tell me what the cosine of 60 degrees is.
Wait, but wouldn't it be easier just to keep it without finding the reference angle and just keep it negative 60 then? Just like go like, oh.
There is an easier method to use, but it involves learning more trig. And I didn't know if you knew the other trig. So there is an easier way, but let's finish out this way and then we'll go back and do the easy way. What's the cosine of 60 degrees?
The cosine of 60 degrees is adjacent over opposite.
No. Adjacent over hypotenuse. Okay, what is that here?
Okay, so that means if it's 60, that means it would be 1 over root 3.
It's 1 over 2. 1 is the adjacent, 2 is the hypotenuse.
Right.
Okay, now we're in the fourth quadrant. What's the plus or minus sign?
It'll be minus.
Cosine is positive in the fourth quadrant. That's what ASTC means, is those are the trig function that are positive in those quadrants. A is all of them in the first. But only sine in the second, only tangent in the third, and only cosine in the fourth. So it's a positive 1/2. Okay? Now, you mentioned an easier way to do this. Let me show you what it is. Instead of converting it to 300 degrees as the first step, it's useful to know that cosine is an even function, which means the cosine of minus 60 is exactly the same as the cosine of plus 60. So I don't have to go to 300 degrees and then back to 60. I can immediately go to this step. But you have to know that. You have to know it's an even function so that the cosine of a negative angle is the same as the cosine of the positive angle. And now that immediately gives you 1/2, but you still have to know that you are in the fourth quadrant. Not really. Cosine of 60 degrees is in the first quadrant. That's plus 1/2 gives you the same answer. But 2 fewer steps. In other words, it's not always most advantageous to convert that negative angle to a big positive 300 degrees. If you are aware that the cosine of a negative angle equals the cosine of the positive angle, then you can immediately do that step. Now, that's not true with sine and tangent. The sine of a negative angle is equal to the negative sine of the angle. In other words, the sine of negative x is equal to negative sine of positive x. And to me, that's the best way to handle negative angles, is with these odd-even properties that trig functions have. If a function is even, then the case with the cosine applies. If a function is odd, and sine and tangent are both odd, then the trig function of a negative angle is negative the trig function of the positive angle. That's still the easier way to go, rather than converting all of these to these big angles.
Yeah.
Okay. Let me erase some of this stuff so I've got some writing room. I'm going to leave up the stuff I want to leave up there, although I almost am hesitant to leave it up, because when I leave it up is all you do is look at it and give me the answer based on what you're looking at. And that's not the best way to memorize stuff. The best way to memorize stuff is to constantly be testing your memory. In other words, you don't write down so katoa, you try to figure it out and hopefully you'll be correct, and then it gets into your memory and you've got it memorized. So I'll leave these up here for now, but please try to memorize these two triangles. And by memorizing them, I mean know these dimensions, because this gives you your first quadrant trig functions, all 6 of them, for all your 3 common first quadrant angles, 30, 45, and 60. All right, so let's look at 13. So based on what I just said, 13 is equal to negative sine of pi over 6, which is 30 degrees. This is the easy way to do it. What's sine of 30 degrees?
Sine of 30 degrees is opposite. It would be 1 over 2.
There's your answer. I don't have to think about which quadrant it's in or anything, because the sine of 30 degrees is first quadrant. So I'm working with a first quadrant angle immediately. It's just there's a negative sign in front of the sine. Okay, let's do the same thing with cosecant of minus pi over 2. Cosecant is reciprocal to which function?
Sine.
Which means, what's the cosecant of minus pi over 2? The same as, in terms of cosecant. In other words, it shares the odd-even property of sine, because it's the reciprocal. So it's negative cosecant of pi over 2.
Yeah.
Well, cosecant of pi over 2 is 1 over the sine of pi over 2.
Yeah.
What's the sine of pi over 2? That's a quadrangle. That's 90 degrees.
The sine of pi over 2 is, let's see, it'd be,
It's 1.
what?
Yeah, it's 1. Remember when we did our, did we do our units, or I don't know, I have so many trig students, I can't remember if I've been through the unit circle lesson with you. If we've never done it, we should do it.
I know about the unit circle, it's just like I
Well,
don't have...
okay, here, let me tell you what I'm talking about. 90 degrees is that point right there, correct? Where I put the x? That's the 90-degree angle?
Yeah.
What are the xy coordinates of that point?
Would it be 1, 0?
No. The x-coordinate is 0, so it's 0, 1. Now, here's the trick. The x-coordinate is always the cosine of theta. Always, no matter where you're at on the unit circle. The y-coordinate is always the sine of theta. So when I say, what's the sine of 90 degrees, it's the y-coordinate of that point. It's 1. And you can get your sines and cosines of your 4 quadrangles in this manner. In other words, this point here is 1, 0. That tells me the cosine of 0 degrees is 1. and the sine of 0 degrees is 0. This point over here is minus 1 comma 0. Tells me the cosine of 180 degrees is minus 1. You see what I'm doing?
Yeah.
That will give you all your quadrangles, multiples of 90. This one down here, that's 0 comma minus 1. What's the cosine of 270?
The cosine of 270, that would be opposite.
No, you can't use that when you're doing these quadrangles. You absolutely cannot do that. These quadrangles are 90-degree angles or multiples of 90-degree angles. So when I say 270, I'm talking about that angle. Well, the x-coordinate is the cosine of that angle, the y-coordinate is the sine of that angle. So what's the cosine of 270?
Okay, the cosine of 270 would be 1 negative 1, 0.
It's not a ratio, Sam. The cosine is the x-coordinate of that point. What I'm pointing at it. What's the x-coordinate of that 270-degree point?
0.
That's what the cosine of 270 is, 0. What's the sine of 270?
Negative 1.
Okay. Let's go back and look at 180. What's the cosine of 180? I can hear you, yes.
The cosine of 180 is negative 1.
What's the sine of 180?
0.
You see how easy this makes doing all 4 quadrangles?
Yeah.
But you have to remember that the x-coordinate is cosine of theta, the y-coordinate is sine of theta. No matter where you're at on the unit circle. When they ask you to memorize the unit circle, that's basically what they're doing is they want, if they say what are the coordinates of that point on a 30-degree angle, well, the coordinates are the cosine of 30, comma, the sine of 30, which would be square root of 3 over 2 for the cosine and 1/2 for the sine. So the coordinates on this point of the unit circle are root 3 over 2, comma, 1/2.
Okay.
Okay? So, let's see. What do we want to do next here? I see a word problem. Word problems are just triangle problems disguised. It's really easy to take a word problem and draw a triangle from it, and then you're solving the triangle. So, what next? 18 looks good.
I'm just looking.
19, did you convert to degrees and do this, or did you work with 2 pi?
I think I just, I didn't convert to degrees, I just...
Good, because it's easier not to convert to degrees. In other words, first of all, that's in the unit circle. That's like 1.5 pi, right?
Yeah.
So if I want a negative angle, then I'll subtract 2 pi. Well, what's that minus 2 pi? 2 pi is 60 pi over 30. So what's my negative angle? What's the answer to 37 pi over 30 minus 60 pi over 30?
It'd be negative 23.
Negative 23 pi over 30. There's your answer for the negative angle. For a positive angle, I'm going to add 2 pi, or add 60 pi over 30. So the positive angle is 97 pi over 30. That's the way you do coterminal angles, and notice how much easier it was to stay in radians. That's a lot of math to convert that to degrees. And then have to add 360 and subtract 360 and then probably convert it back to radians, because I'm sure that if he gives you the angle in radians, he wants an angle back in radians. If your teacher doesn't do that, I'm going to be really shocked. All right, what next? We got about 5 minutes. Sir?
Okay, let's see. I think, I don't know.
You're good with the conversion factors?
Yeah, the conversions are just like where you add the 180.
You don't add it, you multiply it.
Yeah, multiply.
But the secret, there is a secret to the conversion factors. Let's make sure you know what it is. You got to get rid of the degrees. Well, some of these conversions are pi over 180, some of them are 180 over pi. Well, the one you use is the one where you lose the degrees. They cancel, and you end up in radians. Now, if I'm converting radians to degrees, then it's not pi over 180, it's 180 over pi, because I want to lose the radians and pick up degrees. That's all you have to know about the conversion. The conversion factor is pi over 180 or 180 over pi, depending on which way you're going. Okay, so that takes care of 20 through 23. Arc length. Arc length is actually pretty easy if it's in radians. It's S equal R times theta. If it's in degrees, then you need an additional conversion factor, which is pi over 180. So it's one of those two, with S being arc length. So in this problem here, it looks like you've got 2 pi times 8 times 210. That's one way to do it. That's not the easiest way. The easiest way is to use the formula. Notice that if I use this formula, it's just plug in at this point.
Yeah.
R is 8, so it's 8 times 210 times pi over 180, which is what you ended up with. Not really. I don't see a pi over 180 in yours. You've got 2 pi. I know the way you did this was to figure out what the full circumference was, and then to multiply that by, so 2 pi r is the full circumference, and you multiplied it by the ratio of what we're looking at, which is 210 over 360. That's not a bad way to do it. I don't have any problems with that. It's a little faster to probably use this, and they do teach you this formula. Whether they've taught it to you yet or not, I don't know. But you don't have to use that formula. You can always do it the way you did these.
Yeah.
If it's in radians, it's much easier to use the formula, because then it's just S equals R times whatever theta is in radians. It's far simpler to do it this way than it is to do it this way.
Yeah.
All right, Sam, I'm going to let you go. I assume you're off to school?
Yeah.
All right.
Thank you.
You're welcome. Have a good day. Talk to you next time.